Hello everyone, welcome to a Learning at Lambert Labs session. Today Tom Schaefer is presenting, so take it away, Tom.
Thanks, George. So yeah, today I'll be talking a bit about concurrency in Go. So that's the Go programming language, also known as Golang, some people call it. Yeah, and so I'll give a quick introduction to Go. So it's an open source programming language designed at and supported by Google. There are a few kind of lead developers, but one of them, one of the people who created and implemented Go was Ken Thompson, who was the original designer and creator of Unix, so the Unix operating system, back in the 70s. So yeah, it's got some quite high, kind of high level names behind it. So some key features of Go are it's a compiled language and also statically typed, so similar to kind of a more low-level language like C++, but it's garbage collected, kind of similar to a high-level language like Python, and gives you that memory safety that you don't get with, again, a language like C++. We have to manage memory manually. It's highly performant, so again, kind of a good balance between the lower level and higher level languages. And the reason I'm going to be talking about it today is it's got very strong inbuilt support for concurrency. And another advantage is it's kind of simple to learn and highly readable, which is similar to Python. And also, I guess, just a basic level of what concurrency is. Concurrency is basically the ability to execute two processes at the same time, which again, Python has support for, which I think we've had a Learning at Lambert Labs session about that before, but Go has some more kind of interesting paradigms and slightly stronger support for it, which I thought I'd talk about it today. Yeah, so I'm going to quickly dive in and show a Hello World Go program, and I'll just kind of step through this. So all Go programs need a package, and I'm just using package main because only the main package can be executed. So yeah, you can kind of just ignore that first line. Imports at the top as well. So this funct is just the formatting package. Again, don't need to worry too much about that. We always need a main function in our main package that's the only thing that's executed in a Go application. And then here I'm just defining a string, hello world, and then I'm doing funct.println s. And if you hear me saying funct, that's just because people pronounce this as funct, FMT, just short for format, I think. So yeah, and then I will run this. So I guess just stepping back a second. So there are kind of two ways of running a Go program. You can build it using Go build, and then you'd give the file, and then that would output and then you need to give and then we'll just say test. I think I've got that in the wrong order. There we go. And so then you see there's a test file there that's created. So that's a compiled executable. And so you can just run it as any executable essentially. So just test there, and we see hello world. That's one way of doing it. The other way is doing basically both steps at the same time. So if you just do go run and then the file name, then you can see there, got hello world. And just in case you're wondering why I've split them all into separate folders, it's again, as I said, you can only have one main package and one main function per Go application, so per folder essentially. Yeah, and so that's a quick kind of hello world program. So again, stepping back, going high level for a moment, thinking about the use cases of Go. So a lot of really popular kind of DevOps tooling uses Go. So for instance, Docker, Kubernetes, which most software engineers will use somewhat regularly. They're both written in Go, which I guess is kind of testament to the language, and it can be really very highly performant where it needs to be, which obviously both these applications it does. Terraform, another kind of popular tool, Prometheus as well, both written in Go. Some databases like CockroachDB, which is sort of a cloud native SQL database that's just meant to be really hard to take down, hence the name. For anyone interested in cryptocurrencies, Ethereum, which is the most popular client implementation of Ethereum is written in Go, although there are some other implementations in Python, C++, and so on, but less popular. It's also used widely. A lot of big tech companies, given a few here, but I think most larger tech companies use Go to some degree. Also Google being the kind of inventors and creators, they use it a fair bit. Yeah, and now again at Lambert Labs, most of our work, or back-end work at least, is in Python. So I thought it'd be interesting to kind of compare Go to Python. So some advantages of Go compared to Python is, again, as I said at the start, it's statically typed. So again, just to recap, you need to explicitly declare, or either explicitly declare your variables, or at least the types of your variables, string, int, float, whatever. Or if you don't explicitly declare them, as you saw in the Hello World application, then Go is still assigning a type. So if I didn't use this notation of : equals, then I would need to do something like var s and then say it's a string, and then Go knows that this is a string. And so, in Python, you could set a variable to be a string, but then you could, you could try and perform some operations on it, like adding it to an integer, say, and you'd get a runtime error there. Whereas Go, it wouldn't allow you to compile the program. So yes, that's one advantage for your runtime errors there. It's much faster at runtime, about 30 to 40 times faster than Python. It's got stronger built-in support for concurrency, which I will show in a moment when we go through some more sort of code snippets. It's got no global interpreter lock. And just to step back again for a second, so in Python, you can write concurrent code in a number of different ways, but that code doesn't run truly in parallel because of Python's global interpreter lock, which essentially prevents you from running code truly in parallel across multiple cores. So only one like thread at a time can run truly at the same time. So so Go on the other hand, you can spread your work across multiple cores, which is definitely an advantage in terms of speed. This final one is potentially an advantage or a disadvantage. It's highly opinionated, which can save developer time. You don't have to worry about tabs versus spaces, or where should the bracket go at the start of your function. It's all kind of decided in advance. Like there's this Go func tool which automatically formats your Go code and things like that. And again, this kind of highly opinionated nature could be a disadvantage depending on your personal opinion. Of course, it does have some disadvantages compared to Python. So it's got a slightly steeper learning curve, but not dramatically so. It's certainly not in the same way as C++ or Rust or another kind of low-level language. Another disadvantage is it lacks many of the features you might expect. One example I've given here is operator overloading. So in Python, when you're defining a class, you can define this _add method, and then you can just do one object or instance of your class plus another, and you can define that behavior. In Go, you can't do that. There are, other features like generics, which is coming in Go, but kind of various other features that it is missing compared to Python, or other kind of languages like Java in the case of generics. There are fewer third-party libraries compared to Python, which you potentially expect, given that it's a much newer language. It's only been around for about 10-ish years, and also code is kind of more verbose. So you need to, as an example, explicitly handle errors as a return argument for your function, or that's kind of more idiomatic Go, I guess, rather than in Python, you can just raise an error and then do a try except block or something like that, which kind of all of this means that code does take longer to write. So advantages, disadvantages, I guess neither is inherently better, that there are just different cases where you prefer either or. So now I'm gonna go through some examples of writing concurrent code in Go. So the first one I'm going to talk about is Goroutines, which is sort of the simplest way to write some concurrent code, which I will jump in and show you an example now. So here we've got an example of using Goroutines. So I've got a function here called say, which takes an argument s, which is a string, and it just repeats 5 times. It prints the string and then it sleeps 500 milliseconds. And then to use a Goroutine, you just write Go at the start of the function call line, and then call the function there. And the same there. The only thing you might notice, which looks slightly strange, is that now and then sleeping 500 milliseconds. And this is because if you don't have that, as soon as the function main sort of finishes, the program terminates. So we just need to wait for those Goroutines to finish. And there are better ways of dealing with this, which I will go through in a moment. But so if I just do that, go run, there you can see. So in a non-concurrent or synchronous application, you would just see these happen one after the other. So you'd see world printed out 5 times, and then you'd see hello printed out 5 times. Whereas here you can see that they're kind of interleaved. So they are truly running concurrently. So yeah, that's a Goroutine. Just shows you how simple it is to essentially spin up a thread and kind of do some or run functions in parallel. Yes, that's Goroutines. The next thing I'm going to talk about is using Goroutines with Waitgroups. So again, as I said in the last example, it's not really ideal to have to work out, or in this case we know, but try and work out how long your Goroutines are going to last. So we're just kind of, we know here it's going to be 500 milliseconds, but if this was reading a file, say, then you wouldn't necessarily know how long it was going to take. So here's an example of using what's called a wait group. And so I'll start in the main function. So here we're just declaring a variable WG, which is just a wait group from the sync package. And all a wait group is, it's kind of just a glorified counter essentially. So you can, you're essentially telling the wait group how many Goroutines are running. And then, so that's where the next line comes in. We're saying wg.add1, we're adding 1 to the counter essentially and saying there's 1 Goroutine running. And then I've just slightly modified this function here, change it from say to say with wait group, just takes that wait group as an argument. And also you might notice there that star just means it's a pointer, which again, I actually didn't mention that. That's another advantage of Go. You can use pointers explicitly rather than in Python, you can't. Yeah, and so we're doing the exact same thing. We're sleeping and printing the line, but then here we're saying wg.done, and then that's decrementing the counter. And yeah, that's done again here. And so when we get to this final line, wg.wait, then this main function is just going to pause until these Goroutines are finished, and the counter essentially it contains is reset to 0. Yeah, and so if we run this, if I run that one, then you can see we get the same effect of the whole function running to completion, but we don't have to do any sort of hacky sleep, under sleep or whatever. So yeah, so that is kind of how you do it in practice. Channels is another interesting concept. So I guess in this example that we gave here, if we got 2 Goroutines, then here they're relatively simple. We don't need to communicate between the Goroutines, but how about if you do want to communicate, pass a variable between them? I mean, there are other ways you could do it. You could kind of share a pointer or something between them, but a channel is basically a nice way of sharing data between Goroutines. Yeah, it's essentially passing information between Goroutines. So yes, so here is an example of channels. So I've got some really simple functions here. One's called pinger, one's called ponger, and they essentially just take in a channel, which I'll come onto the main function later, but it takes in a channel, which again is just a way of communicating between Goroutines. I do have to explicitly say what type of variable the channel can accept. And here the function is just repeating over and over, and it's sending the string variable ping into the channel. And you might also notice this for, so Go doesn't have while loops, but you can get the same behavior as a while loop by just saying for, and then, yeah, and then this would repeat indefinitely. Same with this function, ponger, it just sends in the string pong to the channel. Printer is the final function that we're defining here, which again just loops indefinitely. And this notation here, so again, this notation is saying it's sending a variable into the channel. This notation is saying that we want to receive a variable from the channel. So we're going to receive a variable from the channel message, print out the message, and then sleep for half a second. And then finally, we've got our function main. So we're this notation is just creating a channel, and then we're running these 3 functions, pinger, ponger, printer. And so we expect it to be sending in ping, sending in pong, and then receiving the messages. And yeah, the other thing to note about channels is, so this isn't just going to be able to send in you know, a colossal amount of pings as you might expect. What's going to happen is it will send in the string ping, and then it will it will wait until some, you know, another function or somewhere else where has received that variable. So it's not just going to send in loads and expect them to be read. It can only send one at a time. It will stop until that's received. So you can think the channel only has a capacity of 1. So if you try and send any more strings in, then it's not going to let you until they've been till that one's been cleared. Yeah, so the only other thing here is I'm just waiting to receive input. You can ignore this. This is just me waiting for input, and so as soon as I give the function some input, it'll stop running. Yeah, and so if I do go run and then on 4, there you can see it's just sending in ping pong, which again, and the reason I kind of gave that bit of information about it pausing until the variable has been received is because if it didn't do that, and if there was kind of unlimited capacity on the channel, if it was more like a queue, I guess you know, you could expect, well, we've initially fired up the pinger function, and you know, there could be hundreds or thousands of ping that had initially been sent in. So it doesn't behave exactly like a, you know, or it is kind of a queue, but it doesn't behave like a queue with kind of unlimited length. It's only really got a length of 1, and so yeah, that's why you see ping and then pong and then ping and then pong. Yeah, so that's kind of introduction to channels. Something that you might want to use alongside channels would be this select statement I'm going to discuss now. It's kind of, if you've seen a switch statement, which is common in other languages like Java, I think it's coming to Python if it's not already. Yeah, so it's this select statement is kind of like a switch statement, except it, rather than switching between variables, it selects between channels, and it essentially is waiting on channels. And yeah, you can see in this example that I gave here, when we're waiting for a variable to be passed in from the channel C, as I said, this is just going to pause here until a variable has been sent in. But you might think, well, what if we had, you know, another channel D and we wanted to receive another message, and we wanted to be able to receive input from either of these channels, where you can imagine if there were no variables passing to C, but there was into D, then we'd be stuck here and we would never get to this line where we could receive a variable from D. And this select statement basically allows you to do basically that. And so I'll come back to the definitions of these in a second. I'll just start with the main function. So we're creating 2 channels here. There's word channel and timeout channel. And then I'm running this read word function as a Go routine, and also this timeout channel as a Go routine, or sorry, this timeout function with timeout channel as a Go routine. And then I'll quickly show what these functions are. So read word is really simple. It's just asking, or it's printing out type of word, then hit enter. And then this is just the equivalent of like input in Python, receiving an input into Word. And then if it does receive an input, then it's going to send that input word into the word channel. Timeout is it's basically sleeping for 5 seconds. And then if it, well, after the 5 seconds, it's going to send the true variable into timeout channel. So you can think of this as, it's one Go routine is waiting for input, the other Go routine is going to be announcing when 5 seconds has passed. And yes, it's almost like a waiting for input, but with a 5-second timeout, which is where this select statement comes in. So here's the notation, got select and then case, 2 cases. So we've got the first one is we're waiting on this word channel, and the second case statement is waiting on the timeout channel. If we receive from the word channel first, then we save that variable, which will be whatever the user has inputted here. We're going to save that into this word variable and then print it out. If that doesn't happen in 5 seconds, so again, this select statement is going to be waiting on both of these channels at the same time. If nothing is entered in the 5 seconds, then timeout channel will send true into that timeout channel. And then we'll hit this case statement and we'll just print the line timeout. And then it will, so yeah, as soon as one of these cases is kind of executed, then we exit and then just carry on. And you can see here, there's nothing else. So we'll just finish, finish the function. So if we go run and then 5, you can see here. So first, I'm not going to do anything. So if I don't type anything after 5 seconds, we should receive there we go. True is passed into the timeout channel and it said timeout. Whereas if I run that again, and if I actually type something in, so if I just, I don't know, I'll just type in A, then you can see there, received A. So yeah, all the select statement is doing again, just waiting on multiple channels. And we could have multiple case statements here. It doesn't just need to be 2. Yes, that's the select statement. One last kind of piece on channels is this concept of a buffered channel. So as I'd kind of said earlier, by default, channels only have a capacity of 1. We might want to allow for more of a capacity than just 1. You might, I don't know, you might be expecting tens or hundreds of variables capacity, and you might not necessarily want to wait because again, as I said, there's a capacity of 1 by default on the channel, but also, and I will go back to that previous example where, yeah, you can, as I said, when this variable is sent in, then it's blocked from doing anything else until the variable is received, but you might want to send in a few, a few variables at the same time. So yeah, that's where a buffered channel comes in, and here's just a relatively simple example. So we'd found the channel capacity to be 10, and then here we're just making the channel with a capacity of 10. That's what the second argument is for. And so here we are just looping 10 times in this case, sending in in this case, just the number I, which goes from I up to 9 here, because it's less than. I'm going to send those into the channel, and then here we're just going to receive them from the channel. We're not actually doing anything concurrently here. It's just, yeah, you can kind of see that that we are truly passing in 10 variables and then receiving 10. So if I do go run 6, then there you go, you can see all of these 10 variables passed in and all received. And if I remove this, then this is going to be an unbuffered channel, so it will only have capacity of 1. And so what we should see is an error, which go there, it says all Go routines are asleep, deadlock. And so there's just a deadlock because we've passed in 1 variable, which will be 0 in this case to the channel. And then before it'll attempt to pass in the next variable, which would be 1, but it will pause because there's no room left in the channel, and then there's no other Go routines or anything that's going to receive the variable from the channel, because we don't get to this point until we pass in all the variables. So yeah, there we go. That's where we get the error. Yes, that's a buffered channel. The next thing to talk about is mutexes. So it's kind of idea of mutually exclusive access to variables. So and I guess the easiest way for me to explain it is just to jump into an example. So got this first example here where we've got a counter variable, which is just 0. And then 1,000 times we're going to run this Go routine in here. This is just an anonymous function. So I could have very easily defined this function, up here as whatever increment, but this is just me defining an anonymous function, and then I'm calling it here. Because again, a Go routine, you need to call a function. You can't just say go counter plus plus, it needs to be a function call. And so again, it's very simple. It's just incrementing that counter. And so, yeah, again, we're doing this trick of sleeping. Again, we could use a Go routine, or sorry, a wait group to wait for the Go routines or whatever. But again, this is just simpler in this demonstration. So yeah, we're sleeping, waiting for this to finish, and then we're going to print the counter. And I guess you'd expect, certainly if it was a standard like non-concurrent application, then it would just increment this counter 1,000 times. So I guess we'd expect to see 1,000. That's not what we're going to see. And I will run the code first. So you can see there we get 971. And so if you think about what's happening, well, when Go is incrementing this counter, what it's doing is it's reading the counter from memory, which initially will be 0. It's adding 1 to 0, so 1, and then it's setting counter to be 1 in that case. But you could imagine that because these are running, again, going back to Go, you can truly run applications in parallel. I guess you could do it without, but regardless, you can imagine there are 2 or more Go routines that are going to read counter at a certain variable. For instance, 0, they're both going to increment 0 to 1, and then the first one will set counter equals 1, the second one will set counter equals 1, because again, they both read counter at 0. And so this has clearly happened, whatever, 29 times. I guess that there's been this kind of, in like concurrent reading, incrementing and setting. Which, I mean, of course, that's not the desired behavior. And so I'll just comment that out and uncomment this. And so we can use a mutex to prevent that from happening. So I'm defining a struct here, which is, I'm just calling save counter. So Go doesn't actually have classes, but I guess the closest thing would be, there are kind of a few ways that it replaces classes, but one part of that would be struct, and all a struct is, it's basically a named collection of fields, essentially. So we've got mutex, which is from the sync package, and then the value inside this save counter, which is just an integer. And then we've got a couple of methods. So we define a method by using this kind of syntax rather than passing it in as an argument. On our save counter, again, it's pointer. So not going too much into the details, we're just taking the mutex, we're locking it, incrementing the value, and then unlocking it. And so a mutex, only one Go routine can lock the mutex at a given time. And so it's only when the Go routine has acquired this lock that it's allowed to do anything. Or I guess that's coded into our application. We're only allowing a Go routine to modify this value when it's acquired the lock. And then it's unlocking to allow other Go routines to then do the same. They're going to lock the mutex when it's available and then increment. This is doing a similar thing to get the value. Locking this defer just means this happens after the function is returned. We're unlocking the mutex after the function is returned, and in between that we're just going to return the counter, the value. And here essentially the same thing as before. So we're just incrementing 1,000 times, sleeping until it's done, and then we're going to get the value. And all of this is done using these methods, increment and get value, to ensure that we're using that lock. And so I will just run this, and if all goes well, so there should be 7, then we should see 1,000. And yeah, that's about it, I think. So are there any questions?